Hi Year 11, I'm making this video to help you with understanding global atmospheric circulation and what we have covered in the weather topic so far. So if you remember our first lesson on weather that we had before we left school, you remember we looked at something called insolation, which is how the sun's rays warm the Earth's surface. So I've got a prop to help me. Ta-da! So you can see here it shows the equator, and if you remember, the sun's rays are the strongest and most concentrated at the equator. We've got a smaller surface area to cover as well, so insolation is strong here, which is why it's hot all year round at the equator. The further we move in latitude, so if we move south to Antarctica or north to the Arctic, the insolation is weaker as the sun's rays have further to travel and a larger surface area to warm, which is why it's colder there compared to at the equator where the insolation is strongest. So that's going to help us understand global atmospheric circulation. Global atmospheric circulation is basically how the winds move around the planet. If you think global, Earth, atmospheric in the atmosphere just above the Earth, and circulation kind of in the moving round, which I've got those three different cells: the Hadley cell, the Ferrel cell, and the polar cell, which is what I'm going to talk about. So as we know, the sun's rays are strongest at the equator. So let's look at Africa here. So the sun's rays are strongest here. If the sun's rays are shining stronger here, it's going to heat the air just above the ground. And if that air becomes hot, it becomes less dense and it starts to rise. If you think of a hot air balloon and how they heat the air up in a hot air balloon and it starts to rise and it floats away, that's what's happening at the equator. The hot air is rising, and as it rises, it cools because it's getting further away from the ground, which was warming it, cools, and it condenses when it reaches something called dew point, which is when the gas turns back into these little droplets of water vapour in these big storm clouds or rain clouds. So that's called an area of low pressure, when the hot air rises, cools, condenses and forms these large clouds, which will cause rain. So we go back to Africa here. So we've got this hot air rising, it's cooling, it's condensing, got an area of low pressure, it's going to have these rain clouds. If you think, what ecosystem is hot and wet? Rainforests. So which is where we find our rainforests on our equatorial zone along the equator. However, it gets a bit more complicated than that, because if you think about Africa, we've got the Sahara Desert here, which can't be an area of low pressure because it's very dry. So when the hot air has risen and cooled and condensed here, it will then start to sink as the air is cooler around here, the Tropic of Capricorn and Cancer. So as it starts to sink, it will form an area of high pressure, which brings very dry weather. Obviously still warm because we're close to the equator, but if you think of this almost as a circle, so it's area of low pressure, hot air rising, condensing, cooling and rain, and then it's moving up, it's moving out, and it's cooling the air, so that means it's going to sink because it's less dense and create an area of high pressure, and then it's going to rise up again, area of low pressure, and this is going to form a cell as it's moving in like this pattern: low pressure, high pressure, low pressure, high pressure. And that cell is called the Hadley cell, which produces our ecosystems of low pressure here. So we've got the rainforest, and then we've got our deserts, the savanna here, an area of low pressure. So that's the first cell. I'm going to talk to you about the other two cells in the next video.